live. It says you are live. So, and I mean, I might not be hearable, right? But maybe I am. I don't know. I'll share the link via Twitter. You can get started. Set up the process.
Let me see if we both
So,
are hearable.
and I mean, I might not be hearable.
Yeah, you are hearable. You are here. Everyone can hear you.
I'm hearable. That's
Yep,
cool.
yep.
Okay, cool.
So OBS
That's
works.
awesome, man.
OBS works.
That's awesome. We should run this on the. Yeah, OBS works. Okay, so first thing in the stream, people, don't use XSplit. No, kidding. Or at least if you're using this, pay for it probably.
Yeah.
Okay, cool. So it means it. Yeah. It means are you okay? So are you ready?
Yeah, I am.
Let's wait and see if some other people show up. But even if
okay, I can start maybe because they can go back and.
Okay, cool.
So the first thing what
yeah. Let's go ahead.
The first thing what I think I should do is I should use the amplitude display to basically divide the whole circuit, because it's QFT, as you said, it's QFT. And what you have done is, I liked what you did is you actually implemented the QFT from its basic, but you replaced the whole circuit with mystery boxes. So yeah, that's nice. And so the first thing what I'm doing is
exactly.
What I'm doing is I'm just dividing the whole circuit into sections so that I can see what happens after each section. And yeah, let me put, I can put it here to make it more convenient for me. So it's quite you can say evident while just looking at it that the QFT should work like this, because yeah, the Hadamard gate is perfect. There should be S here, or S here, and the control not down there. So it should have this particular display, because everything is 0. So that it makes sense that it would have a phase 0. And you can say for one qubit and QFT is nothing but a Hadamard gate, and then you move on applying phases whether by an I don't remember the formula, but it's something like e to the power 2 pi something. So it goes from S T S from Z S T blah, and goes down like there. So this output makes sense. It should this is the output that this is the, you can say, the correct output for 2 qubits. 4 qubits doesn't matter actually. Even if I do this, it doesn't matter. So this, it is correct. And this also makes sense because it's a QFT and every qubit is 0, so the phase should be 0. And you can because let me just to prove my point, if I put it in plus, if I put it in first in superposition, then I should have this kind of pattern. I mean, this is quite evident pattern. So yeah, that makes sense. So, everything is fine till here, but as we move here, what we should see here is we should have a pattern. Let me just put a QFT here, simple QFT. So if this is a QFT and this is 0, so what pattern I should be expecting is, I should be expecting every qubit, you can say, to have phase 0. I think every qubit to be having phase 0, and it should be in superposition, because yeah, that makes sense. So this is the output I should be having here, but everything is fine until here, and everything get you can say jumbled or is destroyed here. So this is the particular gate which is wrong, and let me try correcting it, because to me it seems like you are just implementing the QFT from its basic. So I think let me just implement it. This might be wrong. I don't remember the circuit actually, but I remember that it's you can say the amplitude of Z gate. So this was the wrong one. I could say that. I don't exactly remember what you put there. How does it go?
Just the box that you removed was in between the two Hadamards, just so you.
Oh, yeah, okay. Okay, let me just. Can I control Z? Yeah, I can control Z in Quark. So yeah, this is the box here. So I think I shouldn't put it here. No, that makes sense, because it's the gate, the output what I'm expecting should be here. So it's correct to put it here. So if I'm removing this rotation gate, and if I put, I think I get it. If I put it, put a head of my, if I move this, let me just move this for a while. And yes, if I put a T, where is T? And if I put a Z gate, a formalic Z gate, and change it to -1/8, I think. and then I put a head amount here. Yeah, see, this works. Yeah. So I think that actually gives the correct output for the QFT for this 4 zeros. Am I right, Daniel? Because this is not exactly turning the qubits off, so I can't be sure that I am right, but this is the output that we should be expecting for 4 qubits. So can you hear me, Daniel? Am I audible? And Daniel, hello? We are still live. Yeah, we are still live. Hello? So I just got a text from Daniel that there seems to be an issue with his machine, but I think this should be correct output. Let me just check that if I'm right or wrong, because he suggested that it's a QFT. So if I open a Quark and let me just put a QFT, 4 qubit QFT. So this is the output we should be getting for 0 qubits, and this is the output I am getting. So I think I solved the puzzle. And what my intuition here was, what I did, I tried putting an amplitude gate after each section and divided the whole circuit into each sections, and then just follows the basic rule. I don't remember the exact formula that how the you can say the gate goes. I remember that it's something like 2 to something of 2 the power of 2. So I used that logic, and everything makes sense until this point. But after it was after this R3 box, it was in R3 box, rotation 3 box, that things got jumbled and mixed up. So it was pretty certain that this was the wrong gate, and then I just, you can say, I have implemented QFT. So I sort of remembered that for 4 qubits, I think this should be the correct way of doing it, because it just goes from 1 by 2, 1 by 4 and 1 by 8. So it makes sense that this works out, and we get the correct answer. So I think that's it. I don't think I can add anything more to this. This was the whole puzzle, and I think that's it. And actually, let me just, because due to technical issue, Daniel is cannot make it to the stream anymore, so let me just talk about myself. My name is Abhigyan Mishra, and I run a blog by the name of Quiftix. So if it's not an issue, let me just open my blog here. So here you go. This is my blog, and I post things about quantum computing. So what my, you can say, motive behind this whole blog thing is, I'm trying to build a community around quantum computing. I am pretty new, you can say, new in this field myself. I have spent about, you can say, 6 months or 10 months in this field. I'm learning, and what I want is, I want to meet people who have same interests like me, and I want to learn and grow with them. So that's everything there is to be about me, is to know about me. And I would like to thank Uncertain System, you can say, Daniel Collamer and Quantum Intuition channel for allowing me and giving me a platform to be here and to show myself, and to, you can say, I think that's it. I don't have anything else to say. So thank you, and thank you for joining in, and ciao. We are live.
Cool, because I haven't stopped really, the string on my end, so this should be still going on. Cool. So what you should always do when you try some of these things, right? Especially because this is quantum computing, you have only, even in classical computing, you have only tried for one value, right? Like you have said, okay, so it works. It works for the input of 0, 0, 0, right? And kind of, you got it right in the sense that you fixed one of the boxes that had a mistake.
Yep.
But that's really not everything that there is to the puzzle, right? So, for example, what happens when you try with all the classical inputs, right? Like what happens when you, like, does the QFT still work for 2? For the input of 3 and stuff like that.
Okay, let's see.
And kind of compare it maybe with the, you can use another register to compare with the QFT. QFT, and then you will kind of see. So, and if there's definitely
there's definitely some issue.
So you see that doesn't work.
Yep.
So that's kind of that's my point, right? Like it's always like you gotta kind of to make sure that a box works, you gotta try all the inputs. Right? What's beautiful about quantum computing is that usually if it works for classical, like if it works for non-superposition types of inputs, it should work out of the box for superposition inputs, right? Like because of the linear combination nature of things.
So okay, then I have to think about it again. Let me see. Okay, this makes sense. What can I do is can I implement the QFT again on another tab?
Yeah, sure.
Yeah,
you can do that.
Yeah, that would make things
you can do that
simple.
Definitely.
Yes, simple.
So you can. That's a good smart idea what you're doing, right? Because you're basically saying, "Good, I know how the implementation should work."
Yeah.
So let me kind of debug where
I'll just compare it.
Where this doesn't work.
With at what particular block am I actually messing it up? So that's the only way I think I could solve it. I don't know. There could be better ways, of course.
Yeah, no, that's good. I mean, it's the idea, right? So
I think this is right, and is this right, or am I missing something? Oh yeah, I'm missing something.
You're missing one last hard part at the bottom.
I'm missing a hard part. Yeah, what that's the thing. Okay, so this
at the bottom.
This is the
exactly.
So this is the right QFT. It is right. Let me just check it over one. So yeah, exactly. That is correct. That is exactly what I should be expecting. So this is the correct QFT, and it works for 2 output. And let me just try it. Let me just try on superposition. Let me try on superposition. Because then I should get a particular value. Yeah, it works. This QFT is perfect. So this is the correct implementation, and I'm sure not because I'm pretty sure about 2 inputs because I have mostly used it into like on superpositions and all 0. So that's completely opposite because if you put all 0, there should be a superposition. It's like what I'm saying is now I'm pretty sure that this implementation is correct, which I just did here, because for superposition I'm getting 0, and if I put all 0, I get a superposition plus. So that it works. This is the correct implementation. I'm sure about it. And let me just put an amplitude after every step. Yeah,
exactly. Check after every step and then see whether the states look the same, and maybe that should allow you to then pinpoint what the issue is, right? Because you can then correct.
Let me just do it again. Just put it again.
Problem.
Yeah. So 1. Can you just go on and check the stream is okay or not, because it would be too cringy again if I had to do everything again. So
it's okay.
Yeah, please just go and check that.
No, it's okay. Don't worry. And if something doesn't work, something doesn't work out, we'll do sort of a joint video offline if you want explaining everything, because it's definitely been a mess.
it's still the last.
And I think we should do it anyway. I think we should do another video together, sort of an offline one, just record the call.
Yeah. What we can do is what I'm doing is I like SilkQ. I've been doing some few projects on SilkQ. We can work out in future. I think that would make sense. Or any article we'll sort it out in future. That makes sense. Yeah. Where was I? Yeah. So it's still the third rotation, I guess. Yeah. It's the wait a second. It's second and third rotation, or it could be it could be second rotation only, because that would affect the third rotation as well. So it makes sense that if this is wrong, let me. Yeah, that would make sense. Because it makes
exactly.
Sense.
There's a difference in the phase. You don't see this?
I see.
Yeah, exactly.
What I was
exactly.
These are not independent systems. They are one system at
you got
whole.
It.
Yeah, I should have have that in mind. Okay.
Yeah, exactly.
Let me just put it out there.
You got it right.
There you go. Oh, okay, let's put it down here. And where is T? Where is T?
Yeah.
T. Just put T here, and there you go. Yep, there you go. Now that's just for fun.
Perfect.
I'll check it
perfect.
for
you fixed
superposition.
it. Yeah, that's it, man. That's it.
Yeah, I know, but just making sure. Oof. Oh, come on, it works.
Yeah, don't worry. It's good. It's
works.
Good practice. Yeah,
it works.
Yeah.
Yeah,
you got it.
Yeah,
it works. So you see, so basically, the kind of the takeaway here, right, is I mean, it's kind of the trick here, right? Like, you make sure that it works for all the inputs, right? Because the fact that the box works for one input doesn't mean that it works for all the other inputs, and kind of that's crucial. And so the puzzle was designed to work, for some of those errors to pop up, like, only with certain inputs. So that's basically it. Yeah, man. Thanks. Have you talked a little bit about Qubits and your blog and stuff like that?
I'll do it again. Basically, I did, but let's just say that I deleted the previous video because okay. So my name is Abhigyan Mishra, and I run a blog by the name of Qubits, and it's just qftics.com. So it's nothing special. It's just a normal blog. I try to share things as I learn them. So what's my basic intuition around this Qubits thing is I want to build a community, because you see I'm no pro in this field. I've just had, you can say, 10 or 6 months in this field myself, so I'm still learning. But what I want is I want to learn with people with similar interests. So Qubits allow me to share my views, get people's view. So that's it. So if you want, you can go and check out Qubits. And thanks, Daniel, for having me on the stream. And this is a good stream.
Cool, man.
This is a memorable stream. Turn the qubits off. I didn't turn the qubit off. I fixed QFT.
Yeah.
Technically, I'm different.
Exactly. You fixed the QFT, exactly. That was, and this puzzle is going to be available as well, and some variations of these puzzles are going to be available in the web page as well as part of the first levels of the level 10, which are kind of designed to be around fixing algorithms rather than turning the qubits off. I mean, the name of this is just because of the series is how it's called. But cool, man. Thanks a lot, and then I hope that we can collaborate in the future again. And I'm thinking really to do another video with you, and where we kind of explain that puzzle a bit more in depth, and other ways that you could approach this as well, because I have other ideas in mind. So I think that's cool as well.
Yeah, that's neat.
So I'm gonna end up the stream. I'm gonna end up the stream now. Thanks for holding, and thanks for going through all the hiccups with the stream. But it's gonna stay in the cringe history of the channel. But I think that's the beauty of it, right? Like, it's not always beautiful and easy, right? So I think that's it. So I'm gonna stream end the stream and now, and have a good time, and stay tuned for more stuff and more videos. And definitely, I encourage everyone to visit your blog. Yeah, cool, man.
Thank you, Daniel. Bye, everyone. Bye.
Ending the stream.